Okay, well, welcome to the Air Sea Fluxes from Space webinar series. Today we're changing things up a little. We're not really doing a presentation. We really want to facilitate the beginnings of a discussion about what types of input we might need to provide for the next decadal survey on Earth science and applications from space. So Mara, Lisanne, Juan, and I put together some slides. I'm going to talk through them really quickly as an introduction, and then we're going to have open discussion. But before I get started, any comments from anybody? So the goal today is, first of all, just to provide a little bit of background. So our agenda is first to talk a little about what the Decadal Survey is, give some background on air sea fluxes from space, have a bit of community discussion then, and figure out what our next steps are from here. So first to start, what's the Decadal Survey? Essentially, every 10 years, NASA, NOAA, USGS have been commissioning the national academies in the US to put together a decadal survey, a consensus report on space-based Earth observation for the coming decade. So the last decadal survey came out in 2017, which meant that the committee that steered it was started around 2015. And so we've been asking what the timeline will be for the next decadal survey. I talked to Art Chero at the National Academies. He said, if everything goes according to the normal plan, they would put out a request for information in November of this year. The steering committee would be formed in March, just under a year from now. There'd be additional requests for information at that point, likely formations of subcommittees, lots of meetings, discussion, reflection, with a report aiming to be released in early 2018. Now, nobody knows what the funding is at the moment, if this is really going to follow the standard timeline, but in discussions with Nadia Vinogradova-Schiffer, the physical oceanography program manager at NASA headquarters, who says it's going to be her job to write the terms of reference for the decadal survey, she has indicated that nominally they're trying to get this on track fairly quickly. She's not available to talk today, but she said in June she may be able to come to another discussion group and provide a little input on what's happening. So the decadal survey is a really important community effort to put together priorities for the whole community about where we should head, what the priorities should be. And the more organized we are as a community, the more leverage we can have in having a sensible observing system and a sensible set of innovative observations that really help facilitate the science and applications that we'd like to see move forward. So air sea fluxes from space come in many forms. I'm showing a slide that Lisanne Yu showed a couple weeks ago, I think, showing the variety of fluxes that we can imagine measuring, including long-wave and short-wave radiation, precipitation, evaporation, and latent heat flux, sensible heat flux, and winds. These come in different forms. And many of them are measured from satellite at the moment, including radiative fluxes, which come through the CERES program, precipitation, which benefits from the Global Precipitation Project, GPCP, and iMerge data products, and then a bunch of efforts to produce air sea turbulent fluxes, which is something that Lisanne does through OA Flux, and other groups do similar things, putting together the variables that are needed to estimate fluxes from the bulk formula. So you can think about air sea fluxes in categories, and I've just put a bunch of equations up here to try and put this together. These include momentum fluxes, that's wind losing and gaining strength from the upper ocean. So that's things we think about as wind stress or wind work. Heat fluxes, which include shortwave and long-wave radiation, the radiative fluxes, and sensible fluxes, and latent fluxes, which are turbulent heat fluxes. Freshwater fluxes, precipitation, and evaporation, which of course is linked to latent heat flux, and gas exchange, which is the vertical flux of, say, CO2 or other gases. So all of these have covariance quantities and W terms, which we don't successfully measure from space. We end up parameterizing these using bulk formulations. And so we end up looking at quantities, and I've just sort of summarized the types of satellite measurements we might use. So for momentum fluxes, we're looking at wind measurements, scatterometry, passive microwave winds, the potential for Doppler scatterometry, or multi-look synthetic aperture radar, such as Harmony, which the European Space Agency will launch. These have different resolutions and different structures. Heat fluxes, we think about sea surface temperature. SIMR is a European mission that will launch at the end of this decade with high resolution sea surface temperature. Butterfly was a concept proposal as an Earth Ventures to NASA, which was not selected, but aiming to get humidity and temperature profiles near the surface to help get at some of the bulk formulas for heat fluxes. Freshwater fluxes and precipitation has been measured through GPM and iMerge, as I said before. And gas fluxes come through, really we can only get through getting winds, and there have been proposals to try and get better winds to help with that. Then there are questions about what we try and do. There are questions about resolution. Are we aiming for 1 kilometer, 15 kilometer, or 50 kilometer? What's the temporal revisit time we need? Geostationary, daily, every 10 days? What are the relevant time scales? There are questions about swath width. How much should we measure at once? Are we looking for 100 to 200 kilometer wide swaths, 500 kilometers, 1,500 kilometers? And what are the accuracy and precision requirements for the measurement system we need? So that really leads us to community discussion. We need to think about the science goals. What are the major objectives that have been articulated for improving measurements of heat, humidity, momentum, heat exchange? Are there requirements for these objectives that would be useful to specify? What additional objectives should we include? Then there are technical requirements. What do we need for swath width, resolution, coverage, time of day, global coverage? Opportunities, what's available, what's feasible? And then we really need to think about priorities. How would we allocate funds? What are the most important things? And finally, if we can come up with community priorities, how do we communicate them? Do we write a review paper? Do we prepare text for a draft response to a request for information, an RFI? What's the best way to really share the community desires that we identify? So I think that's the starting point. And at this point, we really want to open things up for discussion. So I can stop sharing slides so that everybody can see people more easily. And we have some questions. I guess we're about 30 people, so we could split into breakout groups, or we could have a single discussion. And I guess we're curious what people would like to do, what would be helpful at this point.
Before we move in, do you want to take a few questions if there's any about the...
Yeah, why don't we take
what you
questions
presented?
first, and I'm going to stop sharing for the moment. So questions, thoughts?
I guess I have a question, sir. I don't really know how this process works very well, but it seems to me that eventually the question of practical opportunities or capabilities becomes important in making a document like this or a plan compelling. And I'm wondering if you have anything to say about this at this point, or the approach is just to go ahead to start with the pure science hopes that we might have.
So this is a really good question, and it does steer what happens in decadal surveys pretty strongly. So there's a sense of what the budget is, and I think at the moment nobody has any idea what the budget is. Um, and then there's also a question of what's technically possible. So we could come up with desires that would be um, not feasible at all, or feasible only with sums of money that are not within the realm of possibility. And so that's why a prioritization in the decadal survey is really important. I don't think we've had any notion of what budget numbers might be floated to support what comes in the next decade, but maybe somebody knows. Has anybody heard inklings? Yeah, I see a hand.
Hi, everybody. No, I have no idea about the budget. I only wanted to comment on, it seems like the first decadal survey was entirely driven by technical capabilities, what could be flown. The second was driven by science completely. What do we want to learn? I was thinking the third one will be driven by applications, the way everything, the community has been going, but maybe this is not at all. Just
That's a really good point. Yeah, I think you're right. We're headed towards the third decadal survey in earth sciences. They've been done a little bit longer in space sciences, planetary science. And the first one was sort of a first try, and it was technically driven. And the second one really was tried to be structured around science questions and science variables. And I think the terms of reference are still being drafted for the third one. So this is the moment to leak input to NASA headquarters about how they might write those. Applications could be a big driver. Certainly in the current political climate, that looks like it might be the only place where there's traction. Mark, do you have comments?
Yeah, in the past, one of the big criteria has been what can you succeed at doing? So what applications are actually doable? Nobody wants to fund something that's going to fail. And then the other factor has been with NASA, what's new and cool? So if you could combine new and cool with a new and cool application, it would seem, based on recent history, to be a better combination or more likely to succeed.
Yeah, and I think it's worth noting again that in the last decadal survey, NOAA and USGS were co-sponsors, and they have different needs. I know there are people here from NOAA, and maybe they have perspective on what NOAA's needs might be, but I'm not sure that NOAA knows what its needs are at the moment. So maybe I shouldn't even suggest that.
No, it's kind of a dumpster fire right now.
So I don't know if NOAA will end up being a co-sponsor either then.
but going in this direction, maybe designing questions that are what Mark was suggesting, application driven, new and cool. Might be, of course, science is what everything is driven by, but how do you formulate why do we have to do this now?
Yeah.
Yes.
I think that's a really good framing and transition to the more community discussion oriented part of our agenda today, unless there's other questions now. But I think our goal was or one of the things we're going to do now is I put a link in the chat, and I'll put it in the chat again, to a Padlet. And so for folks who haven't used a Padlet before, I can just share screen briefly. We have 7 questions here, and since we have a diversity of expertise of people here, some of these focus on, say, those technical issues, what technical opportunities or sensor opportunities do we have? Some are more science focused. What science questions, what applications questions should we be looking for? What is on your wish list? What would you like to see in terms of air sea flux measurements, what gaps exist, what types of fluxes would you prioritize, saying that we can't have everything, so given trade-offs in resolution or swath width, temporal resolution, spatial resolution, accuracy, precision, what would you prioritize? We said sensor opportunities, so some of these technical abilities, and saying this sort of conceptual, how do we frame this so that different flux relevant variables don't compete against each other? Instead, we build a full system that comprehensively meets our goals. And then what are science questions or applications goals that you hope to meet? And I think we'll just take a few minutes to write, collect input from everybody, and then move to discussion. And so for those of you who haven't used Padlet before, you can either log in, or if you don't, you'll be a guest. You'll be given a cute username. I'm Admirable Badger if I'm not logged in. So if you want your comment attributed to you, you can sign it, but you just look at each section, there's a plus mark, you click that, and then you write your response. And then you have to click submit, and it will show up. And so we'll just take a few minutes. You can click the link in the chat to do this.
So should we set a time for 5 minutes undisturbed
think
for
5
people to
minutes.
add, like
Yeah.
10 minutes?
We do 5 minutes, and then it can be extended if we need more.
Yeah, that sounds good.
Come back to discussion in about a minute. Back to Sarah. You're gonna talk.
Okay, should we come back together as a group and I don't know if people have had a chance to look through all the comments that we've collected and to put comments or likes on things, but we can do that a bit. But we have a dilemma now. We're a group of about 30. We could divide into breakout rooms for smaller discussion, or we can stay together as a group. And we sort of want to get a feeling from people who are participating, whether you'd like to have a single discussion or talk in a smaller group.
If I may suggest, since this is the first discussion, at least in what I know, maybe it's better to have it as a group before figuring out what are the more important things to focus on, but that's just my opinion.
Okay, any other opinions?
I like the full group idea.
Okay. Then let's keep together as a group. That puts a burden on people to speak up and not to let the fact that it's a group of 30 intimidate you or make you think that your comments are not wanted. People can keep adding to the Padlet too if they feel like they just want to make sure something goes on the record. But maybe we can just sort of talk through the questions in the Padlet and see where there's consensus or where there are things that we want to spend more time on or really bring to the top in the community discussion. So what do you think, Mara?
Yep, that sounds fantastic.
So we might start just with the first question, which asks, what's the first item on your wish list? And among the answers, I want it all. So I think it's pretty clear that there's a lot that people want. Megan's written a long comment about winds, gustiness, sea surface temperature. So I think we have a hard time. I mean, looking at this, I'd say from a community consensus, there's not a single thing where you can say, yeah, everybody knows we need X. Thoughts on that?
Maybe we can pair that discussion with the discussion of gaps, the
Yeah.
second question, where the gaps became more specific, but there's, Megan.
Sorry.
Yeah, go ahead.
So I have a question with this. I mean, are we defending the current capability as well, or are we talking about enhancements and new stuff? Because, you know, in terms of priorities, it's
Yeah, that's a really good question. And that was at the heart of the last decadal survey. So the last decadal survey made a real distinction between the program of record, what was already happening, what NASA and NOAA and space agencies across the world were funding, and what needed to be new. And for NASA, the decadal survey tried to identify new things that would be new science, new innovations, new capabilities. But the decadal survey also made a strong statement in defense of the program of record and continuing the program of record. As we look towards the next decade, the landscape might be really different. It looks like it might be really different. And so we probably do need to think about defining what's critical in the quote program of record and what would be the new innovations that we'd like to see come forward. And I think as a community input to this process, those are really important things to be able to do. So if we look at gaps, I'm reading through people's gaps, and there's lots of discussion of turbulent fluxes, sensible heat flux, turbulent flux, near surface air temperature and humidity.
Extremes,
Also,
that's something else.
also extremes, yeah. And a comment here from Hopeful Tiger, perhaps we miss a clear narrative about why spaceborne air-sea fluxes we have today are not good enough and why it matters. And that's probably a really good point. So what are we failing to measure today and why does it matter?
The diurnal cycle is one thing to consider that we're not really measuring very well.
Yeah. So I put a comment in about high frequency hourly or perhaps 3-hourly measurements, and there's a query to that. Does that mean geostationary measurements? And I think that's actually something where a decadal survey could spend a lot of time on it, because you can get high frequency from geostationary, but you can also do it with a constellation of CubeSats. And so that's where in the last decadal survey, the push was to identify variables, but not the technology to do it. We don't know what this decadal survey will ask for, but you might envision problems that could be solved either with a geostationary system or as a constellation of CubeSats. I don't know if you wanted to add to that.
There are a couple other options as well. There are some different orbits that could be used to emphasize certain types of sampling.
Mm-hmm.
I mean, in some ways, getting making a successful push for additional geostationary platforms could be a very heavy lift, right? Which,
Mm-hmm.
strategically speaking, a bunch of cheap satellites might have a better chance of actually coming to fruition.
And
Or space. Sorry.
yeah, no, that's a good point. And I think the spirit of the decadal survey has been to say, identify the science problems, identify what the challenges are, and then worry about the technology. And so you could, if we say we want to see how storm systems evolve, we want to see how air-sea fluxes evolve through the course of a day, that's perhaps the science challenge. And then the question of how you measure it, it could be left to somebody else. There's a comment here about the synergy between the planetary boundary layer incubator and air-sea flux teams. I know there are people involved in the PBL incubator. Does anybody want to comment on that? Juan, were you involved in the PBL meeting recently?
I was just crashing the party, honestly. I really just wanted to go see the cherry blossoms in DC, and it happened to overlap. But yeah, but yeah, it was they're planning on a mission of some kind, but in the 2030s. It seems like it's going to be a mix of various instruments. Can't remember off the top of the head all of them, but it's not like GPM where it's like you have the core satellite and then you have all the other satellites supporting it. It's just going to be similar to other constellations. But there was some talks discussing air-sea interactions as well in there. I was only there for one day, so I didn't get to see all of them. But I think that is still in the discussion. I think the issue we might run into, at least for us, is I think they're recognizing it's like, okay, we're looking at about maybe getting 1 or 2 vertical observations within the PBL from space, which, we're not going to get into that roughness layer per se, it seems. The workaround might be, I know Shaquille is looking at how we take like boundary layer height, and get a estimate of if you assume that 10%, if you assume the roughness layer is 10% of the PBL height, then maybe that's how you can then estimate the fluxes as well. I know Mark, you've worked a bit with Shaquille on that as well. So, there's other ways to get around, but I will say there's that ultimately the thing is that I did take away is like, yes, that is in the discussion. That is something that is of importance as well. So I don't think it's competing. It's necessarily, there is some overlap there, I would say.
It seems like the planetary boundary layer is the upper half of the air-sea transition zone. And the air-sea transition zone was the subject of an extensive study, which places the fluxes, the boundary between the atmosphere and ocean right at the middle of it, but also says you need to understand what's happening in the bottom of the atmosphere and the top of the ocean.
Right.
And so that way of thinking is probably a good strategy for thinking moving forward.
Yeah, from what I've heard, my impression is that, of course, everybody recognizes that the PBL is largely driven by the fluxes, right? And the wind above the surface. But since every mission is so limited in budget and so how to observe and what instruments, they're kind of leaving the air-sea interactions to the rest of the community. So it's a complementary type of measurement, not in competition. So that's my impression that yes, we do need it, but we cannot do it all. So let's rely on the rest of the community to provide that kind of observation.
Okay.
I think there's another complication in that I think it's very difficult to separate the structure of the flow in the atmospheric boundary layer from the air-sea fluxes. I mean, some source of the gustiness and the intermittency could be associated with organized, embedded coherent structures in the boundary layer. And you have to know them both at the same time. So I don't think it's really scientifically, I don't think it's a reasonable separation of air-sea fluxes from boundary layer dynamics. I think they're intimately connected. And but in an engineering sense, it's a much simpler to try to separate the two problems. And, you're always going to run into these scientific versus technical challenges that I'm not really sure how to resolve it. I think, we're getting from SWOT a better sense of what the coherent structures are in the boundary layer from SAR. And, there are technologies that are there that maybe with a focus towards a combined boundary layer flux point of view could be a major, both technological and scientific advance, hitting both of the two sort of themes that Mark was mentioning earlier.
Yes, and then actually raises a question, if, let's say there are different missions, one focused on the PBL temperature and humidity and the other on the fluxes, since we don't know the time variability of any of these, unless they are flown together, let's say, how do we really observe a process or just measuring statistics as it has been done so far? To observe a process, we need coincident observations of so many different parameters. So that is about strategy. If such missions are selected, how they would be flown together. Obviously, it cannot be one mission answering all the questions. And the other comment I just wanted to make is, again, that if it is just geostationary observations, that's focused, let's say, on the US. We cannot rely that all other nations will do the same. If that's why, if we want a more global focus, that should be obviously done, not in a geostationary sense.
So let kind of elaborate on this. Some of the ideas and questions we're talking about are probably better answered by aircraft or in situ, more in situ observations. So in the boundary layer, some of the questions about turbulent kinetic energy rather than just thermodynamic processes are valid concerns, or Ralph's roles are better measured by aircraft in many cases than satellite, unless we get very high resolution satellite. So we might think of a campaign that says what questions can't we well address from an in situ observation, or what can we do in combination with an in situ observation system that will really push things forward. And I think if we take that approach, we can make a huge amount of progress on boundary layer work.
Yeah, that's a good point. But we can, it isn't just roles, it's, roles and cells, and the lack of either that are important. And there's a lack of either that's actually strikingly interesting in the mid latitudes. But we can get the roles, using existing technology that the US doesn't have, that the Europeans and every other major country does. And so there are things that can be done, but what we know is that over very, very small wind speed ranges, the whole character of the boundary layer can shift from convective to shear driven, and it's going to do that over the course of a day. And getting the timing of those shifts is going to be crucial if you're going to try to capture that in a numerical model. 1 or 2 meters per second on the surface wind speed is going to shift the boundary layer regime from convective to shear driven. And that's such a small amount. And, the precision that's asked for in the scatterometer is, 1.5 to 2 meters per second. So we're looking at transitions that are occurring within the scatterometer precision range. So it's an interesting problem. Is all, I think it's something to keep in mind, is that we may need to do better than we think we're doing right now.
So what's your vision for addressing that? Would you do it in situ?
Well, you need a global perspective. A lot of the stuff that's really interesting is absolutely unreachable by aircraft. I mean, these regions of stable stratification in the warm advection sector of baroclinic storms, you can't reach that with an aircraft. The best observations are going to be in the southern hemisphere, and where are you going to base from? In the incredibly long flights to measure just a little bit. So space is the place, and it's the need for a satellite perspective.
Yeah, I am not trying to indicate just measure it in situ. What I'm saying is that there's some gaps in interpreting the satellite data that could be resolved with in situ observations, and that we need the wider sampling Ralph is getting at.
Yeah, exactly. And in a lot of sense, the satellite is so much cheaper than the aircraft is one point to think about. I mean, you're talking about many hundreds of millions of dollars up front, but to get the comparable type of quality and type of measurements in situ, how many, $10,000 an hour or whatever an aircraft costs.
So the other question is always, what are the resolution requirements for the things you're talking about? Are you thinking about SAR type resolution, where you get aircraft-like sampling scattered over the globe? Or are you thinking more scatterometer type sampling?
I think they're converging. I think the scatterometers are getting finer resolution and the SARs are getting cheaper.
Yeah, SARs may not be getting wildly wider swaths, but we might get more of them at least.
Yeah,
So-
I think you could, I mean, they're putting up cheap CubeSat like SARS now for this. So.
Mhm.
Does that bring us to this next set of questions on priorities and trade-offs?
Yeah, what types of fluxes do you prioritize, and given trade-offs between resolution, swath, et cetera, what's the most important thing? So there's strong votes under the fluxes here for evaporation minus precipitation.
I think the comment was made earlier that to solve a lot of the questions we have, we really need all of these measurements at the same time.
Yeah, and maybe
And
at
I
the
think
same
that's
time.
true. Yeah.
But go ahead.
Same resolution, same time. I don't know if they could be on the same platform.
Mhm.
Probably not, but that would really help us tackle the next generation of, you know what I mean?
Mhm.
If you have 5 things, maybe you can measure 4 and figure out the 5th, but if you have 5 things and you measure 1 or 2, you're still left
Mhm.
without.
What
Yeah.
sorry.
I was just going to say that for weather aspects, we're seeing that both sensible and latent heat fluxes are really important for the initialization and the intensification of the storms. And even though a lot of the power comes from latent heat, you need the sensible heat to actually use it. And we're seeing that for severe weather, which has a lot of applications. So there's trying to think of this from both a weather and an ocean perspective as well.
So, coming back to the need of coincident observations, I really liked what in the past the A-Train did. So maybe one core satellite that has coincident observations, and obviously it cannot cover space and time. So then it can be complemented by a bunch of cheaper CubeSats that provides the temporal changes and also spatial. But at least one system that can observe, let's say, almost everything in a particular orbit might be a strategy.
So I think that sounds great. I know that when people talk about putting everything on one satellite, there is a little pushback. People say, well, NASA tried to do that in the 90s and everything got too expensive. We need to be affordable and compact and make choices. And so that puts a responsibility on us as a community to think how we message this and how we show that we are making choices, even if we really do want everything all at once.
Oh, yeah. No, I didn't mean on one platform,
Yeah.
but A-Train was a great example.
Yeah.
So we want an A-train of cheap CubeSats with each in their own. No, I mean,
An A-train and a B-train and a
Yeah.
C-train and a
yes,
D-train.
yes, exactly.
Yeah.
Yeah. Actually, that might work, really. Cheap satellites flying in formation.
You have the model of Cygnus, right, where they sent up one thing and it launched 8 little mini satellites on the receiver of the GPS. You could design something that would, launch quite a bunch of little satellites going around in a variety of well-planned orbits to capture the diurnal cycling and spatial sampling. And they could, individually be relatively cheaper.
Yeah, and Tropics did that as well. Probably because Cygnus was launched all at once, whereas Tropics was spread out over 2 or 3 launches as well. So that allowed them to spread out even more as well.
Yeah, well, Tropics really wanted to achieve better temporal coverage. But if you want coincident measurements, they kind of have to be really tightly together. So yeah, I mean, obviously, great point. There are examples already on how to do some of these variation.
Well, you
But-
could have like a series of little mini satellites flying in the same orbit behind each other. So one is measuring this, then 10 minutes later, the next one measures the next thing, etc.
Yeah, exactly. Not even 10, maybe 2 minutes later. So at least they're almost coincident.
And then if one fails, you can hope to get another one into that orbit and fill the gap.
Right,
Yeah, or if
because
you lose one thing, not everything.
Mhm.
yeah, because that's one advantage Cygnus had was the baseline was 6 of the satellites need to be operational. So essentially 2 were redundant.
Mhm.
So that's another advantage too. Whereas with previous, when you launch one big satellite, if I remember correctly, I'm still early in learning all this, but there had to be so many redundancies built into that. So that also adds on to the cost as well. So right now Cygnus is down to 7, so it's still within the baseline. So that is another
Mhm.
advantage.
If you don't have to pay for maneuvering too, if you can put up a whole bunch that are just so much cheaper, you can get almost coincident sampling. But the question is how almost is good enough? And that
So,
depends for what we want to do for the science.
so one question is that I think AWS is putting satellites into a low Earth orbit around 610 kilometers. It's what we're hoping to use for Odyssey. Starlink is putting up a ton of satellites. Is there any way to make sensors that are so light and so cheap and so benign that they could ride on a communication satellite and go up with everything? Is that a
I
crazy
think
question?
noise and crosstalk would probably be a serious problem.
Yeah.
Cameras which could observe clouds. Yeah, and cloud heights and so on.
Yeah, we do pretty well with clouds from geostationary at the moment for many purposes.
Yeah.
So one of the refrains is that we know exactly where the top of hurricanes is, but we know nothing about what happens where it actually matters at the ocean surface.
Just to beat the dead horse, SAR gives you a very good idea of what's going on at the sea surface underneath hurricanes.
Mhm.
One of the things that stands out in the fluxes to prioritize is E minus P came up. Is that a baseline? Is that sufficient from existing satellites, or is that something that there's new opportunities?
My understanding is that P has a whole observing system that does not have funding indefinitely into the future, but it's done currently. It's not clear what the future is. And E is latent heat flux, and so that's a turbulent heat flux that we're not measuring. But others may have other opinions. Yeah, Deirdre?
I took some notes in a meeting recently. So apparently, I don't know if it's the communication satellite itself, but there are opportunities for small sensors to ride on commercial platforms, small commercial platforms through SpaceX launches that are actively being looked at. And one of the advantages of these things is that their ground networks are typically very robust.
Mhm.
So yeah, it might not be like Starlink, but it might be, people who are busy taking those high resolution pictures of, people's crops for, commercial surveys
Mhm.
or whatever. So yeah, I think that is an increasing opportunity.
our last two questions before we wrap up, in case there's anything that hasn't been said that folks would like to discuss, or questions you'd like to ask in this.
Wanted to raise an idea, but so, okay, in making an application-oriented study, if we know everything about RC fluxes and then about the PBL structure, why does it matter? So the question is, what happens with the systems that result from the combination of fluxes and convergence in boundary layer and so on? I just wanted to bring the point of the necessity of 3D wind observations or vertical structure of the winds, but that is a separate topic. But I think it has relevance to all of these.
Yeah. So the applications goals end up driving to questions like, how do we get better weather forecasts with more actionable information that lets people make informed decisions?
Exactly.
Where are the gaps in the existing forecast system that would actually make a difference in people's lives?
Yeah, and that brings also NOAA and NASA.
Classically, NOAA would run the forecast system and want the operational variables, and NASA would be getting the science data to test what improvements might be feasible with a new observing system or new capabilities.
Right, yeah.
We might take a look at question 6, because that's an important one. If there is a community vision for how to make advances in air sea fluxes, or air sea fluxes in the planetary boundary layer, or air sea fluxes plus 3D winds, some combination of that in a coherent way, how do we message that so that we actually achieve something in the community, and we don't just get perceived as having infighting and no consensus? So how do we really put forward a consensus view that is that can be acted on by the agencies? And partly that also asks, how do we work within the European decision-making process and the Japanese decision-making process and anybody else's decision-making process to end up with something that actually serves the planet? I don't know if anybody has any vision on that, but I think we have to figure that out if we really want to be successful in advancing the science.
I don't know, maybe a white paper?
Yeah, I see Tony has his hand up.
Hi, Sarah. I wonder whether the next decadal survey will have something similar to the last decadal survey in terms of the science and application traceability matrix, SATM. And if so, if we anticipate that that's going to happen, a useful strategy might be to start from the left-hand side by defining the science and application questions, not as specific as a mission proposal, but on high level, similar to the last decadal survey report, and then go from the left to the right to define what quantity and where the gaps are and where we want to fill it, and then go further to the right to define the more specific concept architecture.
That was certainly the driver for the last decadal survey, to as you say, to identify first the science questions, the variables that were needed, and then leave it to future work to figure out exactly what the best way to implement that was. It doesn't quite work because the questions people want to ask are partly constrained by what people think is technically feasible, but that is the way to do it. We have about 3 minutes left, and we should talk a little about what happens next. So I can share the last slide, or Mara can.
Go ahead. I don't have it up right now.
Let me see if I can do that. Find it first. Okay. So I think what we want to do is figure out where we're headed from here. Okay, let's try that. That work?
Yep, it happened.
Okay. So I'm going to skip this one. Oh wait, I got this wrong. I wanted to go to the follow-up slide.
The
Here we
next
go.
one.
This one. Okay. So for follow-up, I think our questions are, is there interest in continuing this discussion within the context of the webinar time slot or webinar format? Is there interest in writing a community synthesis paper that would be input to the decadal survey? And is there interest in some sort of workshop, maybe at the Ocean Sciences meeting or the AMS meeting, where we might bring people together and talk through some of the priorities? So I think we just want to figure out what the right action items are so that we can begin to organize and corral the community input into some format that can feed into the decadal survey in a useful way. So, opinions?
I'd like to address Deidre's question that she has in the chat. Oasis is talking about planning a 2-day workshop that would be hybrid and happen prior to one of these conferences, like potentially, actually what it's really looking like would be the Scotland Ocean Science meeting in February 2026. And it would be a 2-day in-person hybrid meeting. And so for people that can't travel, they could participate virtually. And, you know, and that would make it much more accessible. And we could have, you know, a half day, say, for the satellite fluxes.
Yeah, that sounds quite feasible.
But Megan, that sounds great. I think the other thing that we can do if people have trouble traveling for any reason and think that long periods of time on Zoom are tiring is to think about doing 1-hour sessions. So using a webinar type time slot to continue discussion in targeted areas. I think one of the questions for us is, will the community be helped if we can produce a synthesis paper? And if so, should it be a white paper or should it be peer reviewed in a journal? And that may be something where we just need people to email comments or share them around, and we'll figure it out as we move forward. Partly depending on whether there's a venue to publish in and what we're being asked to do as a community to help prepare for the decadal survey. But share your thoughts. What do you think? And we should wrap up too, because we're at the end of the hour.
I think that the community paper would be a great thing, but probably it's coming as a third after some discussions and consolidation of ideas.
So maybe the action is for us to, okay, Mark says we need to know more about CubeSat capability. Maybe we need to get somebody to speak to us more about CubeSats. So we had a webinar earlier about CubeSats, but we can get an update or two. And maybe we should, on the basis of the discussion today, identify some targeted topics and plan some discussion sessions for June or July, where we can sort of move forward on some of these ideas and see what directions people would like to go and what has the most legs to really put forward for the decadal survey as a potential concept. Does that sound like a reasonable strategy? Other ideas? Well, people can send email and complain or propose other things, and we'll see what we can work out. And Deirdre says, let's involve ONR. That's a great idea.
They're very keen on the CubeSat idea, and they've got some innovative programs to help develop them right now. So
If you know who to ask, we can do that. Space Force has also been a great ally for some of the things we're trying to do.
Very quickly, what do you think about NASA planning for bigger mission and then collaborating with all these companies that are flying CubeSats and have a lot of interest to provide the temporal coverage, maybe?
Yeah, I think we should find out what's feasible. So, and maybe there's a company, maybe SpaceX or AWS has somebody who's actually thinking about this and could talk to us. Does anybody know?
I mean, there are a couple of companies that are interested in observing temperature and humidity at high resolution, and I think there are emerging companies that want to observe ocean surface wind. But that's separate from, I mean, could be just put as a way to provide the temporal coverage, while NASA provides the understanding of the process.
So that's an interesting way of thinking of it. So, okay, well, let's digest all of this. And we have, the webinar series has speakers scheduled through the end of May after this. Next week is an economist who will talk about the economic value of weather forecasts. I think it'll be really interesting to people. But then in June, we'll hope to get Nadia in to talk a little about where she sees the decadal survey going, and we could try and bring in some people who have bits and pieces of what we've talked about and continue community discussion with a goal of pulling enough ideas together to produce a synthesis report that could be a published white paper with many authors and that would provide useful input to the decadal survey. If you have other visions for this, send email to Mara or Juan or me or Lisanne or Megan or anybody else who can get it to us, and we'll figure out where we're headed. Thanks, everyone.